So I'm got frustrated that there's not like a good video explaining derivatives on YouTube. Derivatives are way too overcomplicated. It's actually really simple. All you need is basic algebra, the chain rule, the power rule, and if you encounter a trig function, then some trig identities and that BS. If you encounter derivative of sine of x, just Google it. You're probably not expected to work it out every single time. What's a derivative? Well, I'm sure you know what a slope is, surely. So what's a slope of this? It's just the changing y over the changing x, or the rise over run. And we got 1, 2, 3. And 1, 2. So just 2 over 3. That's the slope. But if we have some complicated function like this, what's the slope? It's not constant, you know. The slope of these 2 points gonna be different from the slope of these 2 points. So the slopes are different at every 2 points. But what about at 1 point? That's what derivative is. So you take this right triangle, right, of rise over run. And what you do is basically make it smaller, becomes that right triangle. Make it smaller, becomes that right triangle. 2 points are getting closer and closer. And eventually what happens is, right? Eventually what happens is that these 2 points come together into a single point. And, technically it's not possible to find the slope of that single point because there has to be y over x, and these, changing x and changing y needs to be a number. It can't be 0. But theoretically it's possible. In theory it's possible to find a slope at a single point. So the derivative is just that. So let's view this more algebraically. Instead of rise over run, what are we doing? We're actually just taking some function f, right? F of x, taking a function f of x, and adding some number to x. So there can be a change in x, so we can form this here right triangle. Imagine x, and then this point is x plus h. And that's basically what this is. So what we're doing is y1 minus y2 over x1 minus x2. We can rewrite that into this. And it's all gonna be over x1 minus x2, which is this. Is the things inside. So it's x plus h minus x. And these two are gonna cancel, leaving us with h. So that's the more algebraic way of viewing rise over run, the slope right here. This is the slope. Now to find the derivative, we need the change in x, change in y to approach 0. So this needs to approach 0. We can write that as limit of h approaches 0. So we can write that as this. So this is going to approach 0. Well, we can't divide by 0, so how does that work? Well, if you plug in this for x, and then you solve this entire thing, it should cancel, leaving you with some function g of x. And that's gonna be the derivative, and you replace h of 0 when h cancels. So, how does that work? So let's do an example. This is gonna be function f. And if we plug it into our formula, this right here, then we'll get x plus h free. minus plus h. We'll get this equation for this. And then we'll to minus by the original equation, so x3 plus 3x minus 4. Remember to change the signs because we're subtracting here. And this is all over h. Now I'm just going to do a little algebra, and I'm really not going to show you it because it's just algebra. It's just tedious. Just solving this, expanding this into x cubed, x times h, plus xh, blah blah blah, and we're distributing -3 here, so -3x minus 3h. I'll come back once I've expanded this whole thing, and eventually we'll arrive at something like this. And the next step is obviously to just cancel the h. This h, boom, gone, boom, right there. So what we get is 3x squared plus hx plus h squared minus 3. So this is what we get. Yeah, and let's remember that in order to find the derivative, h needs to approach 0. That change in x needs to approach 0. So this is 0. So it's basically x plus 0. So change in x would be 0. And if that h approaches 0, we get this would be 0. This would be 0. We get 3x squared minus 3. 3x squared minus 3. And this is going to be the derivative, the instantaneous rate of change, the slope at one point. So I need to clarify something. The derivative is not the slope at a point. It is the slope at a point for all points. Okay, a derivative is a function. So you can see that this red graph I have here is the function, and the derivative is going to be this blue graph here. So let's take like x equals, no, that's too big, 1. So let's take x equals 1. So at the red graph here is going to be at this point right here. So what's the slope at this point? Well, the derivative, this blue graph right here, gives us the answer. The slope is going to be -7. So the slope at this point is going to be -7. And we can do this at all points. So we can just move this around. That's what derivative is. It's not the slope at singular point. It's a slope at a point for all points. It's for the whole graph. It's not just one point. How do we find the rate of change changing? This basically describes the rate of change. The rate of change means slope, if I haven't said that already. So, you can see this graph going up. The rate of change, or the slope, is also going up. So you can see the graph kind of plateaus here. And we can also see that the slope is at 0. So the slope is 0 right here. It plateaus. See the graph going down, the slope goes down. You can see it's steeper right here, so the slope is greater right here, but gets less and less steep. The slope is smaller and smaller. You can see that with the blue graph right here, the derivative, slope getting smaller and smaller. So yeah, basically, if we plug in some point x equals 4, we're gonna find the slope at x equals 4. Plug in like x equals 10, we're gonna find the slope at x equals 10. And that's the derivative, and it's a long process, but there are shorter. There are easier ways to do it. This is just the hard way to demonstrate the concept. So basically what we've done is make, the slope triangle, this changing y over changing x, we made that triangle infinitely small. So that was just a whole bunch of algebra, which is what derivatives are. Just plug it in. This is the formula you just need to plug it into, and h is approaching 0. It's really just that simple. But there's a shorter way to do this, and that is the power rule. The power rule. The power rule states that given some function x to the power n, the derivative of that would be nx n minus 1. Simple. Let's try it on this polynomial and just apply the power rule. So just plug it in. What's the derivative? And by the way, we can find the derivative of each individual like a variable. We can find the derivative of all these and just add or minus them. And it's really just that simple. If we apply the power rule, that's going to be 4x 4 minus 1, which is 4x to the power of 3. And we do that again. That's going to be 5 times 2x 1, which is going to be 10x. And the derivative of a number is going to be 0, obviously, because it's just a number, so it's a horizontal line, and there's no changing y on the horizontal line. You can't form a right triangle there. This side is going to be 0. So, the rate of change or the slope is going to be 0 on the horizontal line. So, we don't need to worry about this, right? We don't need to worry about this. This right here, this is our answer, and it's just that simple. Just plug it into the power rule, and it's that simple. It's, for polynomials, for basic polynomials like this, just use the power rule and just add them. It's really, really simple. I don't know how I can explain this any further. It's just that. We can get into more complicated functions, right? So let's take 5 to the power of 2x plus 9 why not minus square root of x. Can't really apply the power rule here. What we're gonna do is the chain rule. What's the chain rule? Well, basically says, so you're finding the derivative of, by the way, this is the Leibniz notation. This is basically just saying that you're finding the derivative of y right here. So some function y, which uses the x, some function y using x. The chain rule says that we can substitute x with a variable u, and we can multiply it and do that. So we can substitute x, not x. We can substitute something like this whole thing. We can substitute like something like this for u, and then we can find the derivative of u as well. So the derivative of this is gonna be this multiplied by this. So if we do this example, like we substitute this for u, we'll get 5 to the power u, where u equals 2x plus 9 minus square root x. So this right here, the derivative of this is also a bit complicated. So the derivative of an exponential would be equal to a to the power x ln a. And it's kind of ugly, but that's the derivative of this. So first we find the derivative of this. We're finding the derivative of function y, so let's just make this function y, which would be equal to, as we said right here, 5 to the power x ln. That's a derivative. Oh, and it's not x, by the way. We're using u in place of x. And then we're multiplying by the derivative of this, which would be, if we apply the power rule, this is equal to x to the power 1/2, and the power rule would be 1/2 x negative 1/2, because it's 1/2 minus 1, which will be equal to negative 1/2. And eventually we'll get 1 to square root x. That's the derivative of this. And this constant slope, so it's just going to be 2, obviously. It's a constant slope, so it's just a straight line. It's going to be 2. The slope is going to be 2 at every single point. And this, again, we don't need to worry about that. So the derivative of this entire function would be 1 over 2 square root x. Don't forget that it's negative, so negative plus 2. And we're multiplying this by this. Again, what is u? U is this function right here. So we just plug it in, just replace u with this. And it's gonna look ugly, but that's the derivative. And I mean, you can simplify it or whatever. By the way, this is in parentheses, of course. So it's this whole thing times this whole thing. And that's the derivative. If you want to simplify it, you can, but I'm not gonna. That this whole thing is gonna be the derivative of this. And that's the chain rule. That's how you apply the chain rule. It's basically just separating the function, separating a function like this into multiple parts. So first part would be 5u, second part would be this. But what if you encounter something like sine? What do you do then? Well, what you do is just use this formula. Do algebra, okay? Do algebra. Or alternatively, just Google it. What's the derivative of sine? Google has the answer. Because this right here is extremely tedious. And you also need to know trig identities, like the fact that sine of x over x as x approaches 0, you just gotta memorize these special rules. Special rules for trig. So plug it in. So if you plug it in, you would get sine of x plus h minus sine of x. Do some algebra, should cancel, and you should, according to Google, get cosine. So the derivative of sine would be cosine. And remember, we're applying the chain rule here because it's a lot of stuff going on. We can't find the derivative of this whole thing, so we find the derivative of sine first, and then the derivative of the function inside. So we're finding the derivative of sine of u, which would be cosine of u. And what is u equal to? U is equal to this. And what's the derivative of this? Well, we find it using the power rule, which is rewrite it again as x times x to the power of negative 1/3. And we just use the power rule on that. But first, we have to obviously combine these two. And if you didn't know, multiply means add the exponents. So it'd be 2 minus 1/3, which would be equal to 3. So if we rewrite that whole thing, we would get x to the power of 3 over 5, we'll apply the power rule to that, so it's 5 over 3 x 5 over 3 minus 1, and that's the derivative of this. So this is the derivative, and we just multiply, whatever, take this and multiply it by cosine of u, and again we plug in this for u. So final answer would be cosine of x squared over cube root x times 5 over 3, and that'd be 2 over 3, so x 2 over 3, and that's our final answer. This right here, for the derivative of this function. That's the derivative. You can simplify it, maybe. I don't think you can. That's just the function of the derivative. So again, if we want to find the slope of a point at x equals like 2, we can just plug it into a function and you'll see what we get, and that's gonna be equal to the slope. So yeah, that's basically derivatives, just making the triangle infinitely small, rise over run, just infinitely small, and apparently you arrive at something like this, when to make it infinitely small.